this is problem E of the educational DP contest. Okay, it's Knapsack 2. So essentially what we have n items. They have a weight and a value, and we need to maximize the value of some set of items given the maximum capacity is W. Okay, so how do we attack this? Obviously, we can try everything, but, that's like 2 to the n, right? You either take or don't take anything, that's 2 to the n. Or we can do it one by one and see how we can work off the previous answers, okay? So, let's see what we can, let's see what we can work with here. In the classical knapsack, we store a DP. We essentially store a DP of, all the values and the weights, and we say, okay, up to using the first I elements, and given this weight, what is the maximum value? Okay, and you loop over that, and you look back, you say, okay, for each value, each weight from before, if I add my weight, making sure that the weight doesn't exceed the maximum, what can I, if I add my value, is that the maximum for, the DP of I plus 1, where the weight is including my new knapsack value. But here we can't do that because W is 10 to the power of 9, right? So that's way too much. But as we can see, VI is at most 1,000 and N is at most 100. So that means V max, the max value is 10 to the power 5, and we can certainly iterate over N times V max, okay? So what we can do instead is we can basically reverse this, okay? And when we have DPI and DPJ, essentially I is going to be, for each value, up till this item, if this is my current value, right, what is the minimum weight? And obviously this has to always be less than or equal to V max. Okay, so how are we going to, okay, so let's just write the pseudocode here. I is going to be from 0 to n minus 1, depending on 0 or 1 indexed. And then J is going to be from 0 to Vmax, which, as we know, is 10 to the power 5, right? And then basically we're trying to say, okay, given these, whatever is the minimum, right, to reach this, minimum weight, which is dpij, if we add the weight for my new value, right, which is I plus 1, then if this is less than, this would be W, right, W max, then we can update the value, right? So what the new value would be I plus 1, we're including the next character, or the next item, and J is the value, right? So we add this value here, and then what we do is you do the min of whatever is in here already, like, whatever you have so far, minimum of this, and the weight for just DPI, J, plus the weight of our new value. So this basically says, okay, if we can keep weight under that max, then now we can update the DP, say, starting from this base point, which is using all the items up to this one, this is the value we get, and this is the minimum weight. We can update that for the new value, which is now including this. And now, essentially, what we can do is now, for DP of n minus 1, we would basically check from 0 to V, and we would check if W max, or if this weight here is less than W max, and we'd also check if this is, if this is possible, right? So there's multiple ways you can do this. The easiest way would just be to initialize this whole DP matrix to like int max, right? Except for, DP 0 and, 0, right? Which would be, you're not including anything. So this is the editorial. I hope it makes sense, and I hope to help you guys out. Thank you for watching, and I'll see you in the next one.